Now, when you're referring to a population, as we said, we use rho to represent the correlation coefficient. And when you are testing a hypothesis, you state the null hypothesis in terms of rho. For example, when you're doing a correlational study, you are testing what we call the null hypothesis. We are testing the null hypothesis. Now, from your previous study of mathematics, when you studied sets, you studied about the intersection of sets, the union of sets, you studied about subsets, and quite a few other things about sets. And you found out what we meant by the null set. Here we have the null hypothesis. When you think of the word null, what do you think of? Right. You think of none. And that's exactly what the null hypothesis means. It means none. Whatever you're talking about, it means none of whatever you're talking about. When we're talking about a correlation coefficient or a relationship, the null hypothesis means that there is no relationship or no relation between the variables. The null hypothesis states that there is no relationship or no correlation between the variables. Now, when we are testing a hypothesis, we state the null hypothesis in terms of the population measures, the parameters. So instead of writing R is equal to 0, which would mean that the correlation coefficient is 0. If you have no relationship, that's what it means. It means that the correlation coefficient is 0. To write this in terms of rho, we would have rho equals 0. Rho equals 0. So that's how we would write the null hypothesis. And the null hypothesis, furthermore, we use the symbol H sub 0. H sub 0 for the null hypothesis. And you can see why we use H sub 0. Because null means none, and 0 really means none. 0 means that you don't have any. So that's why we call it H sub 0, the null hypothesis. So usually we write H sub 0, semicolon, rho equals 0. And if we say that there is a relationship, if we say that there is a relationship between two variables, if the number we get for R is bigger than the number in the table, we'll be saying that there is a relationship between the two variables. Now, the null hypothesis says that there is not a relationship between the two variables. So if we said there is a relationship, we would be rejecting the null hypothesis. We would be rejecting the null hypothesis. So this is what you'll be doing. When you look in the table and see that the number that you got for R is bigger than the number in the table, you will reject the null hypothesis. And you need to state this when you're writing up your problem. You need to state that we are rejecting the null hypothesis. And you need to tell why. You're rejecting the null hypothesis because the number you got for R, the absolute value of the number you got for R, is bigger than the number you found in the table, or bigger than the critical value. That's your reason for rejecting the null hypothesis. And then, of course, you state your conclusion. There is a significant relationship between the two variables. Now, if you say that if the number you get for R is smaller than the number in the table, then you are saying that there is no significant relationship between the two variables. In this case, you are accepting the null hypothesis because you're saying that there is no relationship, and the null hypothesis says that there is no relationship between the two variables. So you are accepting the null hypothesis, or as some authors indicate, you are failing to reject the null hypothesis. Failing to reject the null hypothesis is the same as accepting the null hypothesis. So, depending upon what you see when you compare your value of R with the critical value in the table, you should indicate whether you are rejecting the null hypothesis or accepting the null hypothesis. Now, there's one other concept we need to discuss, and that is what we call the alternative hypothesis. The alternative hypothesis. Now, the word alternative in this case really means the opposite hypothesis. And this alternative hypothesis or opposite hypothesis is just the opposite of the null hypothesis. It's just the opposite of the null hypothesis. We call it H sub 1. That's the symbol that we use for the alternative hypothesis. Now, if the null hypothesis is rho equals 0, the opposite hypothesis, or the alternative hypothesis, would be rho is not equal to 0. Now, these two hypotheses are opposites. If you reject one, you automatically accept the other. If you accept one, you automatically reject the other because they're opposites. Now, to summarize, we have discussed the correlation coefficient. If both variables are decreasing at the same time, and or if both variables, once again, if both variables are decreasing at the same time and or increasing at the same time, then we would expect a positive correlation coefficient for those two variables. If one variable is increasing as the other is decreasing, then we would expect a negative correlation between the two variables. Once you use the formula that we mentioned to compute the correlation coefficient of two variables, you need to decide whether or not that correlation coefficient is significant. To do that, you need to use table A-6. You look at the value of n. You look under n in the table until you see your sample size, or the number of pairs that you have in the data set. And then you look across from n for alpha equals 0.05. That's the 0.05 level of significance. That means that you want there to be a 5% chance of error if you conclude that there is a significant relationship between the two variables. You look under alpha equals 0.05, come straight down under that until you're even with the sample size. And there you have your critical value. You look at the value you got for R, look at you got for R, and If it's bigger than the value in the table, you have to say that there is a significant relationship, in which case you would be rejecting the null hypothesis. You have to state your chances of being wrong. On the other hand, if the value that you got for R is less than or equal to the critical value that you find in the table, you have to accept the null hypothesis or fail to reject the null hypothesis, and you conclude that there is no significant relationship between the two variables, and you do not state your probability of error.